Day everyone, welcome to Wise Lake Academy. We are going to be looking at an aspect in physics. In our last video, we discussed on work. So today I'm going to be discussing on energy. So now, this class is for the SS1 students who are trying to go to SS2. So if you find this video helpful, please kindly click the subscribe button and like. Let's proceed. Energy. In our last video, we talked about work. And I said work can be defined as the product of force and resistance. And I gave you a series of formulas based on work and how to attempt to work done problems. So today I'm going to move towards energy. What is energy? We all understand the terms, we all hear energy every time. So now what do we call energy? So energy can be defined, as you can see, energy can be defined as the ability or capacity to do work. The ability or capacity of an object or a body to do work is called what? Is called energy. And take note, I said something in our last video that work is measured in joule. So, and I said that work and energy are both measured in joule. So their SI unit is in what? In joule. Now, that's the definition for energy. Let's proceed. The forms of energy. This energy we're talking about is classified into different variations. So let's look at an aspect, the forms of energy that we have. We have the mechanical energy, the heat energy. That heat energy is also called the thermal energy. You want to get that now? When you hear the word thermal energy, it simply means heat energy. So don't get confused when you see that in a question. So we have light energy, we have chemical energy, electrical energy, atomic energy, and solar energy. These are the forms of energy that we have in physics. So there are still many, but these are what I can give to the SS student for now. But where I'm actually going today is the forms of energy. Number one, I'm going to treat this aspect, mechanical energy. Mechanical energy is subdivided into two. We have the kinetic energy and potential energy. That is where we need to work on. Let's proceed. Now, we are under mechanical energy. Under mechanical energy, we have what we call the what? The potential energy and kinetic energy. Under mechanical energy, we have what we call the what? The potential energy and the kinetic energy. So, what do they mean? Whenever you hear the word potential energy, listen to me very well, is the energy possessed at rest. When a body is in a position, for instance, I am in a position, this pen is in a position, and this pen throw a ball. That pen has easily performed an energy, but in what state? In a position state, in a potential state. That is, the body is not moving, but it performs energy. So such kind of energy is called potential energy. And potential energy is given as PE. It's noted as what? PE. Which we can easily say that potential energy is equals to mathematically is equals to mass times gravity times height. Whenever you hear the word calculate the potential energy of a given stuff, the formula that will come to head when you hear the potential energy is what? Mass times gravity times height. And note that our m is what? Mass in kg. You get that now? Our gravity, g's are what? Acceleration due to gravity. So why the last one is what? H is our what? Height. In what? In meter. Gravity is what? Meter per second square. Do you get that? So let's not take an example. Let's take a look at an example on this aspect. For instance, you are given a question. You know I said potential energy, kinetic energy, work, and energy itself as a whole. Their unit is what? Is in joule. So don't forget that. So now, for instance, let's take a question. Find the potential energy of a body of mass 10 kg. Can you hear? Find the potential energy of a body of mass 10 kg. So we have to find the mass of a body of mass 10 kg. So we are given what? Let me write the question out. Now let's look at this example. They said find the potential energy of a body. Can you see? Of a body of what? Of mass 10 kg standing on a building floor 10 meters above the ground level. As I always tell my students that whenever you see a physics question, the first thing to do is write out your parameter. So what are parameter here? You have said what? You have to find parameter. We are given what? We are given our mass to be what? 10 kg, isn't it? Mass 10 kg. Find the potential energy. P. We're looking for it, isn't it? So find the potential energy of a mass of what? 10 kg. 10 kg. Standing on the building floor of what? 10 meters above. That's our height. 10 meters. So we are asked to find what? Potential energy. So recall that our PE, potential energy, is equal to what? Mass times gravity times height. But if you notice that our mass is given and our height is given, but we all know gravity as what? As a constant value, which is what? 10 meters per second square. Look at it here. 10 meters per second square. So our acceleration in gravity is what? 10 meters per second square. So now we can quickly look for our potential energy by saying potential energy is equal to our mass is what? It's given as 10 kg. So write a 10 kg. 10 times our gravity is 10. You understand? So times 10. Times our height is what? Our height is what? Also 10. You can see that now. 10. So potential energy is now equal to what? 10 times 10 times 10 will give us what? On a 1000. So 1000 what? Is it 1000 work or 1000 joule? Our answer is what? It's in joule because they are all energy. Likewise, if you calculate for kinetic energy, so you'll be having what? The answer in joule. So joule, you can see that now. 1000 joule. So this is how to calculate for what? potential energy. Let's move forward. Kinetic energy. Kinetic energy. Kinetic energy can be defined as the energy possessed in motion. Whenever a body is moving and an action is taking place, so it is said to be what? A kinetic energy. So now let's look at an example based on this. But before we give this example, what is the mathematical representation of kinetic energy? You can say our KE is equals to 1 over 2 mass times velocity square. So take note that kinetic energy is what? 1 over 2 mass times velocity square. Where our what? M is what? The mass in kg, and our V is what? The velocity in meter per second. Isn't it? So we can now proceed. Let's take an example and let's view how kinetic energy is being solved in a problem. For instance, we are given this question. As we are saying, we want to look how kinetic energy is being solved in physics questions. For instance, we are given this question like an object of mass 5 kg is moving at a constant velocity of 15 meters per second. Calculate the kinetic energy. It's simple and basic concept. Just what you need to know is your formula and apply them. But I told you before you solve any physics question, write out your what? Parameter. What are you given? So parameter, our parameter here will be what? Let's read. An object of mass 5 kg. So we have mass as what? 5 kg. Okay. Is moving at a constant velocity. You can see it's moving at the what? Constant velocity. So that tells you that it's the kinetic energy. So at a constant velocity of what? 15 meters per second. So V is what? 15 meters per second. Calculate for kinetic energy. And note that kinetic energy is also denoted as what? Ke. So now they said what? Find Ke, kinetic energy, isn't it? We can now proceed by saying that our recall that kinetic energy is equals to 1 over 2 mass times velocity square. You can mathematically this becomes what? If I work on this, it becomes mass times velocity square over 2. It's still the same thing. You get that now? So now, therefore, our mass is what? 5. 5 times velocity is what? 15. So 15 square. Velocity square. So we have 15 square over 2. Isn't it? If I work on this, I'll be having 5 times 15 square will give us what? 15 square. 15 square will give us 225. We'll be having 225 divided by 2. Isn't it? So if I work on this again, 5 times 225, I will be having 1125 divided by 2. So when I divide it by 2, mathematically it will give me 562.5 joules. Don't forget. That's what I was doing, joules. Joule. Do you get that now? So this is how questions on kinetic energy is being solved. If you find this video helpful, kindly click the subscribe button and like. Thank you. In our next video, we're going to be doing more example based on kinetic energy and work done. Thank you very much.